All right. All right. So let me see. Welcome, scholars. So we are at the tail end of week. I think this is like 13, right? So just to kind of want to take a moment to just do an overview of what to expect in the coming weeks. One, we're essentially in the home stretch. We're rapidly approaching the end. Everything is for this semester is going to be over in a blink of an eye, right? So things that you need to be aware of. Let me see. So a proposed or anticipated schedule of events. Let me see. So we have this week we're working on section 3.1 exponential functions. Today we're going to go through as many of the homework questions together as we can. Then next week, I think we have supplemental income, not income, but supplemental material, right? Section 6.4, I think it is. It's further topics in algebra. Namely, we'll probably be working on solving a system of equations. The week after that is Thanksgiving. So that the week of Thanksgiving, we'll meet that Monday, and more than likely we won't meet on that Wednesday. And then so enjoy your holiday break. And then after Thanksgiving, that's the last week of class. So November 30th, which is the Wednesday, we meet on that Monday and Wednesday. That Thursday and Friday, even though we don't meet on Thursday and Friday, but that's supposed to be the reading period, so you shouldn't be meeting in any of your courses. And then the following week is the week of finals, right? So that first full week in December is the week of finals. Your final exam should become available that Sunday. I think it's the December 4th, whatever that Sunday is right before the week of finals, the first full week. It should become available that Sunday at 11:11. So what that means is, go ahead.
My bad. Professor, I have to ask, speaking of exams, do you look over the exams or if
no,
or is it just what's final grade is what final grade is?
Well, I don't look over them unless you bring something to my attention. Now, I had a student in my previous class, he felt like he got it right. I was like, well, let's look at it. So I pulled it up. And he had the right answer. He just didn't follow the instructions, right? It said put it in decimal form, put it in fraction form. I checked it. So I went on to give him credit for it, right? Because it was correct. He just didn't follow instructions. So if you know, if you feel like you got something right and you want me to look at it, just bring it up now and we can look at it and then, go from there.
Okay. Can we just email you after class or do it right now? Because I don't want to disrupt your lesson.
Well, this is really office hours. I just fill it with the lectures, so we can do it. What's your last name?
Clements, Clemens.
It was on exam 3.
Yeah, it was the most recent exam.
You know which question?
I'm pulling it up right now. It was I think it was a couple of questions. I got the answers right. I just didn't put it in the right. I didn't put it in the right. What you call it? Right format. So it didn't one of them I got you. But one of the questions, it was the answer was 1, but I didn't put x equals 1, so it didn't count.
Okay, let me look at it. Hang on. Allow.
Is it gonna let me look over it again? No, it's going.
I can see it. I just got to pull it up. Grade book. I want to view. Managed by student. Allow. And, okay, I got you. Okay, I have that you took it once, so it must be this one. Okay, let me review. Allow. So let me see. Do you know, was it one of the ones you got partial credit on, or do you know which question?
Yeah, it was. I think it was one of the partial. It was a couple of the partial credit ones. The ones I got wrong. I know I got those wrong for real. But the partial credit ones, I know a couple of them. I just didn't put it in right. I just didn't put a number. I mean, put an X or a comma before it. But I know I got the answer right itself.
Yeah, one of them, I remember the struggle it gave us when we did this in class, and it's usually 1 point that's off. I'll go ahead and give you credit for this one, just because I know how, sometimes that one is a little bit trippy. One of like I'm looking at a graph for one of them, so it gave you half credit. I'll just give you credit for that one because it really should allow you to type the points, and for some reason it doesn't. Let me just hit submit grade. So there's one of them. There's question, and I gave you credit for question 16.
Okay.
Look at 13. Here it is. Type a 0, but you answered. Oh, you put 9.7, and it should have been it was just wrong. You put the wrong answer.
Okay.
Yeah, I'm gonna let that one stay. Let me check this one real quick. You put, yeah, the wireness up. It says you put 7 and the answer was -7, and it gave you some credit for it. That one was wrong too. That wasn't the right one. Let me look at this. Let me see. -3 plus the square root of 2, -3 minus square root of 2. Oh no, that was wrong. Yeah, no, that was just wrong. This one, axis of symmetry. Oh, I see. Okay, I can give you credit for that one. Let me see. You answered, and that was just wrong. It's not full credit. I can just give you more credit for that question.
No, that works for me. I mean, as long as it.
Yeah, I get no. Like you definitely want to try to try to recover as much as you can here, because like I've had where something similar in the student. We went through it and I was able to give him some credit, and it bumped him up by a letter grade, so he didn't have to go back and redo it. Some of these are just wrong. So if it's just wrong, not even close, then I kind of leave it. Yeah. But if it's close,
I'll take my on it. I'll take my own.
If it's close enough, I'll see what I can do. You answered like this one. I can give you credit. Okay, that's fine. So I can switch this one. Was this the one I just did? Let me see. Come on. Where is it? Why? Okay, here it is. Okay, how many points they give you? Let me see what else. And the graph. Correct answer, you answered. Let's see, what's the difference? Oh, I see. It's close. I don't know about that one. Yeah, I can look at it and see. And that's not difficult. I think the graph, I'm gonna let that one ride. But I can give you, let me see. Because I can see what part of you got right. So I'll change it to like this. Oh no, 0.8. Just more credit for that question. I didn't give you full credit on 5, but I gave you some. I think I went through, let me check. What is this one? Wire intercept. Yeah, I think I went through this one already. And then this one. Why is it wrong? This one. Correct. You answered. Yeah, I think we did that one already. Okay, so I just went through the ones where you got partial credit, and I just kind of gave credit where I could. Let me see. Yeah. I don't think it changed it that much, but it did improve it a little bit. Okay.
Mm-hmm.
All right. Okay. Yep. No worries. But yeah, that's so I went on and took the time because that's actually the intent of this time. Like for us to meet, because that's just the way it's designed. That's the way I designed it for if you have a question about something, you want me to look at something, you have, that was the original intent for these kind of things. So that's why I was like, okay, well, let's go ahead and take some time and see what we can do. Let me get these students. This one. Thank you. Oh, this one. This one. He was here. He must have just got booted or something. And then this one. Okay. I think I got everybody. I'm not going to worry about it. Does somebody else have a question? I see another hand is raised. I know we took care of Mr. Clements.
Yeah, I have a question. I just want to know if we could go back on the exam and change our score or like improve our grade? Because I got what I got. It wasn't that bad, but I want to see if I can improve it or work on
Yeah,
it.
yes, you can do that with anything that's on Pearson, right? So I'm glad you asked the question, but so you can go back and improve your overall score on any assignment, right? So if you go back to an old assignment, the highest you can earn is a 90. So if you made below a 90, you want to improve your score, then you just go back. You're still going to limited attempts. The highest you can earn is a 90. You can do that with anything. If you're trying to go back and improve your overall score of your overall grade, you definitely want to prioritize your exams where they count for 80% of your overall grade. So, that's where you're going to get the most bang for your buck. Main bang for your bucks is improving your old exams. The last thing you want to prioritize if you're trying to improve your overall grade is the homework. The homework is going to be a lot of work for little points, right? So the homework is really there to prepare you for the exams. Once your exams are where you want them to be, if you just feel like you have the energy and focus and time to go back to those quizzes and exams, then you do it. But, I don't want you stressing. I don't want you trying to finish all that homework because that's not going to shift your grade. If you really want to see a shift, you got to improve your exam scores. That's where the bulk of the grade is. Okay, that was a good question.
All right, got it. Thank you.
Are there other questions? Other questions? All right, let me. Okay. Yeah. So, yeah, I'm glad. Yeah, that makes me feel better. It's like it is a challenge to get you guys to speak because you don't have to talk. But I do acknowledge that there is a difference. Like if we were in person, you look at somebody in their eyes, there is a distinction, between being live and it's to me it's much more challenging for you all to be remote in that you don't have that live component, right? And so like if you're hesitant to speak, then or to draw attention and just to check and make sure, if you don't take that gumption, if you don't take ownership of the experience, then it's very easy to fall by the wayside. And even with like our starfish and early alerts and things like that, it's still kind of difficult to kind of reach you guys sometimes, and vice versa, right? So I do acknowledge that, but but if you guys want it, it's literally just there waiting for you to take it. Like if you want like a good grade or whatever it is you want, just take it. Like I encourage you to, like for instance, right now you can take this material, sit down with the tutor, sit down with your classmates, and you can work on it together. Like there's nothing wrong with it. Like just get it submitted and try to pick up what you can. Sooner or later, you more than likely you will be in a testing environment where you're going to be responsible for this stuff. But for right now, just try to take some time to learn what you can and try to get it submitted. Right? Okay. I think I just checked Zoom. Let me check one more time. I kind of like train myself now when I see the 15-minute mark to just check to make sure we don't have any latecomers, but that's neither here nor there. Okay. So let's take some time and get through as many of these questions as we can. And I kind of do want to zoom in. Let's see. Am I pressing this right? Maybe it's this one. There we go. There we go. That looks better. Okay. So given this function g of x equals 3 to the power of x, we're asked to find g of -3, right? So this being an exponential, that means our variables in the exponent. A negative exponent causes the base to flip, causes the fraction to flip, right? So instead of 3 to the power of x, the negative exponent flips it to 1/3 to the power, right? So this is going to be 1/3 to the power of 3. So that ends up being 1/27. We're asked to type an integer or a fraction, so we're going to put 1/27. Okay, and again, if anything is not clear, feel free, like the gentleman before, feel free to unmute yourself to get my attention. That's the best way to kind of get your matter resolved. The chat is another option. I do check the chat periodically. For instance, for this one, we're asked for this exponential function, evaluate f of 2.6. This one, we just use a calculator, right? So this is just a calculator examples. Let me see if I got my trusty dusty rusty. Boom, right there. This looks decent. This will work. Okay, let's reload and refresh. Okay, so what I'm going to do for this one in the calculator, in my y equals, I'm just going to type the original. So it's 3, let's see, 3 hats. 3 to the power of 1 minus x. So 1 minus x, parentheses. Cool. So let's quit. Then I'm going to call on that function that I just typed in, this guy, and we want to evaluate it when x is 2.6. Okay. Then we're asked to type an integer or decimal rounded to 3 decimal places. So 3 decimal places would be 172. Behind the 2 is a 4, so that 4 tells us to stay the same, right? So we should just stay at 0.172. So 0. That's not a 0. 0.172, right? Boom. Okay, on to the next one. So given the function, we're asked to find f of 2, right? So we're replacing x with 2, so then that means we have 1/2 squared. That just means 1/2 times 1/2, which is 1/4. So I'm just going to type 1/4. I definitely did not type 1/4. Can I get rid of this? Maybe not. That's okay. 1/4. Okay. Okay, we don't need this right now. All right, so this one, we're asked to find the exponential function of this form that contains the 2 points shown below. Okay, let's do like this. We need to take some notes on this one, so I'm gonna get a screenshot and we're gonna hop over to Pearson, to Notability. This one. Okay. There we go. All right. So find the exponential function of this form that contains the 2 points shown below. All right, so we're starting with, we have this f of x equals c times a to the x, okay? And we're given 2 pieces of information. We're given that when x is 0, y is 9. When x is 2, y is 36. So let's plug those in. Let's just plug those in. We don't have any information on c just yet. We don't have any information on a. But again, when x is 0, y is 9. Let's go ahead and write the second piece. So CA, when x is 2, y is 36, okay? So now in this first one, a to the power of 0, that collapses to 1. So from there, we get that c equals here. Let's c equals 9, right? So when x is 0, a to the power of 0 is 1. 1 times c is 3.
Excuse me, Professor.
Oh, hello?
I can't see what you're writing for some reason.
That's fine. Let me the screen. You guys look good there. Let me share the screen. Thank you for that. Start the broadcast. I don't know, for some reason it kind of keeps crashing. All right, let's try this now. So just you should be able to see it. If not, just let me know. We can try something else. So we started again to kind of recap. So we didn't have any information on C, nor did we have any information on A. But again, when X was 0, Y was 9, right? And then we repeated that for the second piece of information. We didn't know C or A, but when X was 2, yeah, you still can't see it?
No, I can't see it.
Can anybody else see it?
I can't see it either.
Yeah. Maybe this is not working. Let's see. What if I go like this? Maybe if I turn it off, stop the screen share. Zoom, yeah, Zoom is correct. All right, are you able to see it change now? You guys there?
Give me 1 second. Let me see if I can.
Let me see. Let me check on my end. There's something that I can check. That's interesting. This one, all right. But again, when X is 0, I don't like listening to my own voice for some reason. So yeah, that one works. But then, you guys still can't see it? Yeah, I can see that. Okay, let's try this. What is this? You guys still there?
Yeah, we still.
So I'm watching my live to see what I can see on the live. So I'll go to Zoom. Let's just try it again. I might have to like reboot everything. Start the broadcast. And it's weird because this was showing, I saw this come up. Let me see if I can get this to show. Or can you confirm, can you guys see my screen? You should be able to see this one at least, because I know this was working. And I see it on live.
Okay, yeah, I can see it now.
Okay, wait. So then the challenge seems to be when I go to Notability, because it is showing on the live. Okay. So then when I open up Notability, and I think it's Notability OS has done all these updates, and some things might be updated and some might not be. Like some might be ready for the update and some might not be ready. And I think that Notability might not be ready, because that seems to be, it is very like temperamental. It seems like it crashes. See, that's working. I can see that. But see, even right now, there we go. It shouldn't take that long for that to load. Let's see. Yeah, okay, I can see it there. Can y'all see the screen now? Yeah, I see it in the live. So I'm assuming that because I can see it in the live that you guys should be able to see it. Let me see. Yeah, it looks like it's loaded. I'm gonna just go with it, okay? I'll just use my live to just kind of monitor it. Okay. All right, so I can see it there. Okay, cool. Yeah, that was an adventure. And I still really don't know why it does that. Okay, so let's kind of recap. So we have these two pieces of information that we want to model to this guy, okay? So what you see in green. So we just applied those pieces of information to the model. We had no information on C, so I just left it alone. No information on A, so I left it alone. But then when X was 0, Y is 9. Then I plugged in the second piece of information as well. So no information on C or A, but when X was 2, Y is 36, right? So then we notice that A to the power is 0, that guy goes to 1. So then that just means that C equals 9. Then we can take the C equals 9 and plug it into the second equation. Okay, so that was a recap. So then we'll have 9A squared equals 36. Okay, divide both sides by 9, A squared equals 4. Take the square root on both sides. So normally when you do square root, it's plus or minus, but in this context, we don't use a negative. Exponential functions are not defined for a negative base, so we only take the positive here. So then, we have C is 9 and A is 2, and then now we can model our function. So now we get that f of x equals 9 times 2 to the power of x, and we can confirm that each order pair works in this function. Okay, that was an adventure. We got 9 times 2 to the power of x. So hopefully this is still good. Sometimes it crashes. Come on. Okay, cool. So 9 times 2 to the power of x. Say enter. Okay. Let's try another one. Graph the function on paper and then choose the correct graph, right? Okay. Let me see. How can we see this? I guess I need to zoom out. Let's zoom out one more time. So for this one, I would like to do a poll so I can get it to behave properly. That's fine. Okay. We can go this way. Oh, and I think I just got to click on something. Okay. So that looks good. And then let me pull up the poll, which is this one. And we want to start a poll. General multiple choice. Yeah, that looks good. Launch the poll. Okay. So it says graph the function on paper and then choose the correct graph. So this is just an exponential. We have 5 to the power of x, right? So this one is really just asking, what's the general shape of an exponential? Is it A, is it B, is it C, or is it D? So there is a live poll that's available. Wait a minute. Yeah, I was like, yeah, I think you got here a little bit early. Okay, that's fine. Okay. Okay, well, let's see. So general exponential is B, right? So let's just go with that. Okay. Somebody got it. Okay. I'm gonna lock out the poll for right now. We'll come back to it. All right. Oh, here's another one. Sketch the graph. Okay, so let's bring the poll back. Let me see. Yeah, there we go. So if we go to the polls, launch the poll. Okay. So then this one is asking us to sketch the graph of, we have 2.4 to the power of negative x. It says by making a table, or you can use a calculator, right? So with this exponential, normally, you know, the exponential to the far left is close to the x-axis, and then to the far right, it goes off to infinity. And that's when the base is larger than 1. So our base is larger than 1, so we're in the clear. Now there is a vote for C. C is promising. Now normally it's increasing as you go from the left to the right, but our exponent is negative, right? So if you think about transformations, if you multiply the inside of your basic function by a negative, inside manipulations cause a horizontal change. So that's going to cause it to flip, horizontally over the x-axis. Let me see if this student is here. It's okay, I don't see. All right. There's at least one vote for C. Okay, so I would agree with like C. I feel like it's either C or D. So then we just need to make a distinction. Okay, should it be C or should it be D? For instance, when x is -1, we should be at 2.4. Let me see. 1, 2, 3, 4. So when x is -1, we should be at 2.4. Okay, I feel like C is a little bit off. I feel like C is too steep. Because remember, when we're graphing exponentials, we have 3 key points: when x is -1, when x is 0, and when x is 1. So it's a good idea to test those. I think the zeros all pass through the same point. So it's a good idea to test when x is -1 and or 1. I think I'm gonna go with D as well. Everybody's choosing C. Oh, you guys are making me nervous. I think there, when x was -1, it's like that one's showing 5. I'm gonna go with D. All right, I'm just gonna go with D. Okay. Okay, this is another one we can do. Let's relaunch the poll. Now, okay, I ain't gonna lie. Low key, I really want to try. For some reason, I don't know why, and I think there's some applications, or we can find some applications. But I want to like one of the last classes. I low key want to play like Imposter Amongst Us. I don't know if y'all are aware of that game, but I know there's some way where we can do it, like via Zoom, and like we can vote, and we can actually play it. I don't even know why. I just want to do it. I don't know.
I'm down for that.
But like, how do we do it? Like, I know that I think there's an app or something, maybe. I got to see if I can find it. But if you remind me, like, I'm totally open to it. Like that last day of class, like the 30th on that Wednesday, I'm open to it. Just to change up the energy, just to have some fun with the group setting. Okay. So we at least have through G, right? So if it happens to be H, then, we're SOL. But we're asked to match the graph to one of the following functions, okay? So let's see, we do have a general exponential. It looks like that horizontal asymptote is indeed the x-axis, which is y equals 0. When x is -1, that's kind of difficult to see, but when x is 1, it looks like that's 5, right? So any takers, which one do you think it is, if you had to guess? It looks like a general exponential. I don't really see like any manipulations or anything. Like it doesn't look like it's been distorted or shifted or anything. I think I'm just gonna go with A. Let's just try A. Okay. All right, let's do the next one. What's the time? All right, so I think I need to do this one because it's not multiple choice, but I like the multiple choice, especially when you guys engage, just because you get some anonymous feedback. It's generally anonymous. I don't really go checking to see who's saying what or anything like that. But it just makes it a lot more interactive than usual instead of it just being so passive. And to me, I think that's where the fun is. It's like when we are engaging each other. Use your knowledge of transformations to compare the graph of the function given below with the graph of f of x equals 6 to the power of x. Graph the given function. Okay, so we're using transformations. So 6 to the x is a general exponential, right? It's just going to take on an exponential form. And then we have a -3 on the outside. Remember, outside manipulations cause a vertical change, and it follows our intuition. All right, so if you were using transformations, it should just be a general exponential that's been shifted down by 3. So I'm going to click to enlarge the graph. Let me see if we can still see our equation. So we want to choose the exponential tool, which is the bottom left corner, right? This guy right here, okay? I'm just going to click on the graph to open up this menu. The base is already 6. The only change is we need to do a vertical shift down by 3. All right, so that's that's incorporating transformations with exponentials, right? So if you ever have a question as to whether a math final exam is cumulative, by default, math exams are cumulative because I could easily ask a question that's came up towards the end and it incorporates things that we've been talking about all semester long, right? Mathematics is like, it's a stepping ladder. It builds, everything builds on the previous, right? So if you miss one thing early on, then it kind of screws you going forward. You gotta take your time, dot all your I's, cross your T's, and you really want to do your best to try to understand each concept. So that way you can use it going forward. If you miss something, you can't like climb a ladder by skipping 2 or 3 rungs at a time. Otherwise, you're not going to get anywhere. Right? Sketch the graph of this function. Describe how the graph can be obtained. Right? So this is basically exponential function, but I see 1, 2, 3 transformations all together. So we're going to click to enlarge. Let's slide this guy over so we can see our equation. The base function is exponential, so I'm going to click on my exponential tool, and I'm just clicking anywhere on the graph. Now, we do have that the base is 2. Now, the recommendation is whenever we're doing multiple transformation in one function, the recommendation is to work your way from the inside to the outside. So start with the innermost manipulation and then work your way out. So the innermost manipulation is that -1. We subtracted a 1 on the inside. Inside manipulations usually cause a horizontal change and is the reverse of our intuition, right? So -1 on the x direction usually is to the left, but because it's the reverse of our intuition, we actually go to the right by 1. So the first one, we want to do a horizontal shift to the right by 1. Wait a minute. We don't want to reflect. I don't know why I did that. So we did a horizontal shift. Let me see. This should say, oh, come on. Now you're not going to show the option. Okay, can I just restart this thing? Clear. Click. Don't reflect. I don't know why it keeps automatically reflecting. And now it's not showing our options. Okay, let me try one other thing. Let me clear. That's fine. I'm going to bring it back. I'm going to leave. Now it's not showing it. This thing is so temperamental. That's what I wanted though. I was just trying to do it so I could see my tick marks so that I know what I'm doing. So, okay, so the innermost manipulation was the -1 that causes to shift to the right by 1. The next manipulation is that times 3. That's outside our basic function. Outside manipulations generally cause a vertical change and they follow our intuition. So then that should cause the whole thing to do a vertical stretch by a factor of 3. All right. When we multiply the outside by a number larger than 1, it causes a vertical stretch. Okay. And then the last one is that +2 on the outside. So that should cause the graph to shift up, do a vertical shift up by a factor of 2. Okay. Everything else is good. The base of the exponent is 2. I don't know why sometimes it automatically reflects, but I think we're good there. So we're going to go with this. Okay. Let's just go with it. Let's hit save and check. Let's go ahead and do one more. Oh, wait, we need to finish this one out. Okay. So since this one, I would like to get some feedback from you guys. I'm going to relaunch this poll. Launch. So then we have these questions. Okay, so see the A, B, C, or D. It says, describe how the graph can be obtained from the graph of the basic exponential 2 to the power of x, and then choose the correct one below. A says shift the graph of y. We go to the right by 1. That looks good. Stretch it vertically and then shift it down 2 units. We didn't go down. Shift the graph to the right by 1. There's a vote for B. Okay, that looks good. Stretch it vertically and then go up by 2. That's promising. Yeah, that looks good. And then C, left 1. Nope. Yeah, that's not right. So let's go with B. All right. We're gonna go with that one. Enter. Next question. Let's do one more, and then we'll call it a day. Use transformations of this. Okay, so exponential base E. So we didn't talk about this together, but it's definitely my pre-recorded lecture because we just didn't have the time. You know, we only have a 50-minute course. So, you know, I go through the details there, but the rules still hold. This comes out of this formula. When you let n run to infinity, it approaches this number 2.73, yada yada yada. It's similar to pi. It's just a function in the calculator, right? And but yeah, this is base E. And the reason that this is so interesting, the reason this is isolated is because there's this concept in calculus called the derivative. You don't need to know this right now, but you know, if you have a curve, you have this thing that's called a tangent line, where it's a line that's going to intersect the curve at one point, but it like grazes the curve. It doesn't cut the curve. If you think about a curve, you can cut it hard, like at a 90-degree angle, or you can like graze the curve, right? So the lines that graze the curve at one point, we call those tangent lines. And so the derivative is the slope of the tangent line. So then with E, with the function E, when you're looking at the graph of E, the derivative of E, the slope of the tangent line of E at, I guess when x is 1. And long story short, the slope of the tangent line of E is itself. It's kind of bizarre, right? And so it was like an interesting case. So it's a main thing that we use in a lot of mathematics. For our purposes, it's just a function in the calculator. It's similar to pi, but this one is a function, and this is like a number like 2.73, something like that, right? But the properties of exponential still hold. Let's go ahead and finish this one out. So we're using transformations. I see 2 transformations. The innermost transformation, we have that -1 on the inside, right? So they should paint an image in your mind. And then we have that +1 on the outside, right? So let's see if we can capture those two. We got our exponential tool. I just clicked anywhere. We got our base of E. So that -1 on the inside causes it to go to the right by 1. So I'm going to click horizontal shift to the right by 1. And then we added 1 on the outside. So that causes a vertical shift up by 1. So that should be it. We went to the right 1 and up 1. I'm pretty sure this is outdated, but for some reason that made me think of like you know, the finishing move in Mortal Kombat, you know, ABBA, left, right, up, down, finish them, you know. Left, right by one, up by one. Let's check and see how do we do. Okay, we did fine. All right, and that is essentially time. Are there any burning questions? Oh wait, let me see. Which equation represents the asymptote, right? So because we went up by one, normally it's y equals 0, but because we went up by one, it's going to be y equals 1. All right, type in equation. Okay. The domain of this, the domain in a graphical sense is the very left to the very right. So in general, the domain of an exponential is all reals. Okay, so I'm going to say negative infinity to positive infinity. Okay, and the range normally is 0 to infinity, but remember we moved it up. So instead of the open interval from 0 to infinity, it should be the open interval from 1 to infinity. Okay. So we get infinitesimally close to 1, but we actually never reach it. Okay, that's enough. Okay, so let me take a moment to share our notes, and while I'm sending this, give you an opportunity to kind of think of any questions if you have any. This is College Algebra 1. This one. Notes. This one. Yeah, again, you have a copy of everything. Not only do you have a copy of like work that we've been doing, but you also can access my notes from other classes, and you can watch their presentations as well. I feel like my best presentations are at the 9 a.m. because I'm like, I'm fresh. I'm just waking up. My mind is clear. I don't have no kind of like itis or anything like that. By the time I get to like my 3 o'clock and 4 o'clock, like around this time, man, I'm ready to take a nap. Like, I'm struggling so hard. I feel like, man, guys, can you just like watch my presentation from 9 a.m.? But it's neither here nor there. Okay, guys, so if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, have a great weekend. Take care. Peace.